Hello, this is Ravel Nugmanov, software architect from One Way Automation. In this video, I would like to demonstrate how do we test our application ogamma Visual Lager for OPC. In this case, we are going to figure out what is the performance of collecting data and storing in the timescale DB database. And for that reason, we have deployed three components in the cloud. All of them are in the cloud. One of the virtual machines is Windows. It runs OPC OS server from Unified Automation. We have 500 instances of servers running on that virtual machine, and each server we have 500 variables monitored in each server, so it brings us a total number of variables monitored 250,000, and each of them are sampled with 500 milliseconds interval, which is 2 times per second. So total number of data values collected is 500,000 or half million. And another virtual machine runs Ubuntu 2022, and both these virtual machines have 30 gigabytes of RAM and 8 CPU cores. And the third component is database. It's PostgreSQL with timescale DB extension. It's cluster of 2 nodes, each with 15 gigabytes of memory and 4 CPU cores. So this is the setup. And now this one is Windows machine where US servers run, and I have a remote desktop connection to it, and here are these OPC US server instances. And to start this number of servers, we use a PowerShell script, 500 number of servers, and it creates a configuration file with a port number starting from 48010 and increments it by 1 for every instance. And we can see here number of total processes in the PC exceeds 1000. So I believe if we look at here, so these are server processes. Okay, so this is where UE servers run, and another VM is with Ubuntu, and you can see here configuration, and here is the GUI with to configure ogamma Visual Lager for OPC. And we can see here server number 01, 02, etc. And where's the end? It's refreshing. I have to tune off so it will not interrupt my browsing here. So these are server connections, and we can look at connection data. The application process is busy. It's why now we have some delays. And we had to increase timeouts because when we create connection to all these servers, it takes some time. It doesn't connect very quickly. If we have just one server connection, then timeout is by default 1 second or 1000 milliseconds. In this case, we set it to 30. Here we can see that number of good variables is variables with good status of data is 250,000, and here we have when I click one server, it shows how many variables are for this server. For each of them 500, and if I click here for all servers, then it will show how many variables are total for all servers. Okay, and this is where Ogamma Visual Logger for OPC runs, and the third component is database. It's PostgreSQL. We can see 2 nodes, and each with 4 CPUs, and we can see metrics, how it's using resources, and we can see that CPU usage, one is 80, 90, and another is about 50. So there is some room here, and there is some room on the OPC web server machine too. And if we look at the machine where Ogamma Visual Logger for OPC runs, we have CPU usage is close to 100, and memory is used by this process 20%, which means 20 from 30 gigabytes, it will be 6 gigabytes, right? So it's not very doesn't require too much memory, but CPU, we need a little bit more CPU to handle this load. And now if I go to Visual Logger for OPC GUI, we can look at statistics dialog window. It shows what time series database we are connected to, and how many space that a local storage occupies in the local disk, and then how many data values were collected and stored in local storage and then forwarded to the remote database. And we see that there is some significant balance still left being stored in the local storage, because rate of forwarding data values to the time series database timescale DB is around 70,000 values per second, while collection rate is close to 500,000. We can see that we need to do some optimization to store to the database. We did not do any optimization. Maybe we need to do some optimization on the database side, or maybe we need to a little bit optimize our site. We'll figure out that. So this is the current state of our performance testing. We are continuing to improve our product, and eventually we will reach I think 500,000 data values per second forwarded to the database too. And with InfluxDB, we have better results of storing, but with PostgreSQL, we need a little bit optimization. Thank you for watching. Have a great day. Bye.